For this question, the first thing I need to decide is if a precipitate forms, what is the precipitate? So if I'm looking at a reaction between lead 2 nitrate and lithium chloride, my choices are which one of these has the potential to precipitate? I know that all nitrates are soluble and all group ones are soluble, so it's definitely not that one. Is it PbCl2? Well, if I go to this chart, I find that PbCl2 indeed has a KSP value, indicating that it's a likely suspect. PbCl2 has a KSP of 2.4 times 10 to the negative fourth. So that's the precipitate of interest. I am going to write a dissociation equation because I need to have the KSP expression. And my KSP expression is going to be the concentration of lead 2 times the concentration of chloride squared. What I need to do is I need to get Q. I need to find the concentration of lead and plug it in. I need to find the concentration of chlorine and plug it in and get Q and see how it compares to KSP. Now, the issue with these problems is we have dilutions happening. So I have 20 milliliters of lead 2 added to 180 milliliters of this. That means it's going to end up diluted by the other substance. 20 milliliters of 0.003 molar. 180 plus 20 is 200 milliliters. So after the two are mixed, the concentration of lead ions is going to be 0.003. I'm going to do something similar for the chlorine. I have, so dilution of Cl minus. Starting off, we have 180 milliliters of 0.18 molar chloride, diluting to a volume of 200 milliliters once the two are put together. So 0.18 times 180 divided by 200. Or in this mixture, the chlorine concentration is going to be that. Now I'm going to calculate Q. Using the KSP expression, difference is I'm using initial concentrations instead. 0.0003 times the concentration of chlorine ions squared. And I get Q to be 7.87 times 10 to the negative sixth. I need to compare Q to KSP. My KSP is 2.4 times 10 to the negative fourth. Q is less than KSP. No precipitate forms.